Okay, the second half of Worksheet 3D for the Math 4 course. Picking up with number 8, we had already figured out that R, where did it go? R was 0.1815 and some change. So we can use that for future. At this point, we can kind of rewrite the generic as that equals the sample. They're still saying, whatever sample. So we're going to stick with 100 pounds of the stuff that we started with. E to the negative 1/8. I really would like a couple of more decimals. Let me go back to my calculator. 18158. We'll call it that. 18158 T. And this time it's to 20% of the original. And so we're going to divide both sides by 100. That's going to give us 0.2 equals e to the negative 0.18158 t. And I am now ready to write this as a logarithm. Log e of 0.2 equals that. Which is natural log of 0.2 equals that. All right, so natural log of 0.2 is negative 1.609. By the time I divide that by negative 0.18158, it gives me 8.86, about 8.9. How long will it take the sample to decay? Should be about 9 days. It should reach that just short of 9 days, so we'll call it 9 to be safe. 8.86. Okay. Now, here we have Newton's law of cooling. We need to find the function of t of t, where the first number was the initial temperature, which should be 98.6. And the surrounding temperature is 70, so the difference would be 28.6. And then we know that K is 0.1947. And T would represent the hours after death. So now we've got a formula that we can calculate how, if we have a temperature now, we can solve for how many hours has the body been dead. All right. So if the temperature in the body is now 81, so we would say 81 equals 98.6 plus 28.6, the negative 1947 t. So now we got to get t by itself. So we're going to subtract 98.6 for both sides. We're going to wind up with negative 17.6. And then we're going to divide both sides by 28.6. And let's see what that gives us on the left side. 17.6 divide 28.6. It's going to give us about 6.615. So I'm going to turn around and write that as a logarithm. Log base E of that decimal equals that decimal. That's what I thought. Something is wrong here because I've got a negative in there and it won't let me do a negative. Body begins to cool. Temperature is now 81. All right, I just figured out what happened here is that I got the two numbers backwards. We're going to have to back all the way up. I hate to do that on notes, but I also really hate to re-record the last several problems. We're going to back all the way up to here. All right, these two numbers are backwards. That's where the problem was. I didn't have the formula written in front of me. All right, this is supposed to be the difference between the two, and this is supposed to be the room temperature. Wait a minute now. No, I did have that. I just had this wrong. This was supposed to be 70. This was supposed to be 28.6. That's where I went wrong. This first number is supposed to be room temperature, and then this next number is supposed to be the difference between normal and room. All right, so let's start this again. When I subtract 70 for both sides, I get 11 equals 28.6 e to that. And then I'm going to divide both sides by 28.6. And 11 divide 28.6 gives me 0.3846. Equals e to the negative decimal t, which I'm going to bring that decimal over here, and we're going to rewrite this as log of e and this decimal and the exponent goes over here. And then we'll write this as natural log of this. And then we'll figure out what the natural log is of that number. And then we'll divide both sides by the decimal on the right. All right. So natural log of 0.3846 is going to give me negative 0.945 in a row. Interesting. And then I divide that by negative 0.1947. I get 4.907, so it's about 4.9. Now, this was in terms of hours. It was not quite 5 hours ago that the body would have died. Okay. Now we get to play with the turkey in the oven. All right, so our formula is going to start out. If the turkey is at 140 after half an hour, so 140 is what it was. Room temperature is 72. The difference between the original 185 minus 72 is going to be 113. And the initial time after 30 minutes, it was 140 degrees. So now we should be able to figure out what K is, and then we can go back and figure out what was the temperature after 45 minutes. All right, so if I subtract 72 from both sides, I get 68. If I divide both sides by 113, I don't think that's going to reduce. So I may just leave it that way. And just put it into our logarithm that way. Log base E of 68 over 113 equals negative 30K. Oh, that's right, I gotta have some room. Did I set this up? No, I didn't. I gotta save myself some room here. All right, let's just take this a step at a time. Natural log of 68 divide 113, parenthesis, enter. $507.88. And so I divide that by negative 30. $16929. So that's what we're going to use for K. That is the temperature after 45. 72 plus 113 times e to the negative 0.16929 times 45. So I'm going to say second e negative 0.16929 times 45, close the parenthesis. My E is going to be like 4.9 E negative 4, but then I'm going to multiply it by the 113 and add 72 to it. And that is going to give me 72.0555. So what is the temperature after 45 minutes? Temperature should be 72 degrees Fahrenheit. All right, when will the turkey cool to 90? So 90 equals, and we'll borrow the rest of that, 72 and 113. All right, so we are going to subtract 72 from both sides. And we're going to divide both sides by 113. So I should be able to rewrite this log base E of that fraction equals that decimal which is natural log of that. So first of all, let's find the natural log. Natural log 18 divide 113, close parenthesis, bam. That should be about negative 1.837 and some change. And then we're going to divide by negative 0.16929. And we get 10.85. So we'll just call it about 11 minutes. Almost there, one more. All right, so a kettle full of water is brought to boil in a room with a temperature of 18 Celsius. Now boiling is 100 Celsius. After 15, it drops down to 75. Find the temperature after another 12 minutes. Now understand, that's not 12, that's actually 15 plus 12 minutes. That's 27 minutes. So first order of business is to figure out what K is for boiling water. All right, so we're going to have to start with the first one that said that it boiled down to 75. Room temperature was 18 degrees Celsius. The difference from 100 to 18 is 82. And the first go was 15 minutes. All right, so we should be able to find K from there. So if I subtract 18 from both sides, that's going to be 57. And then if I say that 57 divided by 82 is equal to E to the negative 15K, I'm going to turn around and rewrite this as log base E of the fraction equals negative 15K, which is natural log of 57 over 82 equals that. So natural log 57 divide 82. It's going to give me negative 0.36 and so on. And I'm just going to go ahead and divide by negative 15. And that gives me 0.024244 as my K. Now I could turn around and do this again for 27 minutes. Remember, 15 plus 12. So the temperature, we got to figure out what the temperature is after 27 minutes. 18 plus 82 e to the negative 0.024244. And the time is 27. All right, E raised to that number, negative 0.024244 times 27, parenthesis, E is going to be about 0.5, and I multiply that by 82, and then I add the 18. And that's going to give me 60.6. So that would be, the temperature would be about 60.6 degrees Celsius after another 12 minutes. And that is it.